I'm a researcher from Baidu XNAB, and I'm interested in AI security and natural language processing. Today, my topic is tracking fake news based on deep learning. Well, my presentation consists of these 5 chapters, so let's get right to the point. With the rapid development of the internet, information dissemination has become more and more convenient. We enjoy the convenience, but also suffer some risk. Recently, public opinion attacks have become more and more common. Attacks purposefully fabricate rumors and fake news. These negative articles widely spread across the internet, such as Twitter and WeChat. Often, negative public opinion has a bad impact on individuals, companies, and the stock market. Online short attack is a typical public opinion attack. In the past few years, many well-known public companies have suffered many short attacks. And these attacks push these companies' stock price down sharply. Often, short sellers anonymously post fake news about the targeted company. Then, when the company's stock price down, falls to the bottom, these short sellers will buy a lot of stocks. After a period of time, when the stock price recovers, these short sellers will immediately sell out these stocks. So these short sellers will make a profit from the decline in this company's stock price. Moreover, some attacks fabricate fake news about individuals with some social influence, so as that they can ask for some money to protect personal reputation. Companies' pride and the stability of the stock market. It's so necessary to tracking anonymous articles. However, these rumors and fake news are mostly anonymous, and each lack effective discriminating information to identify its author. So it's so challenging to track the fake news. Fortunately, we have found that each author has a distinct writing style. As shown in the left table, there are 2 tweets by different authors. We can distinguish the author's identity from the writing style. As shown in the right table, the writing style can be divided into these levels, such as next gen, character, syntax, and semantics. For example, different people have a different preference for the usage of words. Some people like using some certain words, and different people like using different words. So we can identify this author by the word frequency. And more generally, we can track the fake news by this writing style. And there are many related works about this problem. So let's have a look at this method. In this related work, the problem of tracking the anonymous articles is defined as the authorship analysis. It contains these 3 sub-problems. authorship attribution is really a problem deserved research. It identifies the article's author from a given list of candidates. And author verification is also an interesting problem. It verifies whether the authors of the articles are the same or not. And all the clustering is two cluster articles of the same authors. To better track anonymous articles, we can combine this approach to three sub-problems. Authorship analysis is a long-standing problem, and it was initiated by the work of Mostler and Wallace in 1964. According to the timeline, we can divide this problem into three stages. In early 2000, some papers proposed a method of stylistic and content features. These researchers manually extract lexical, character, syntactic, and thematic features. Around 2010, some researchers proposed a method of character Ingram, and this method has been proved to be the most effective features. And in recent years, with the breakthrough of deep learning, the method based on deep learning networks was proposed for the authorship attribution. These existing methods have obvious shortcomings. Firstly, the method of stylistic and content features take a large effort to manually extract features. It's so difficult to select the most effective features, so the performance is poor. And the method of character Ingram represents text into high dimensional and sparse vector. So the performance is still limited. And the method based on deep learning have obvious shortcoming. It can't be applied to all the verification and all the clustering. So we propose a novel method for authorship analysis to make up for its shortcomings. FastNet is a unified method for face recognition, face verification, and face clustering. It has achieved a big success in computer vision. Inspired by the FastNet, we proposed a unified method for authorship analysis. So, based on the deep learning network, our method then are mapping from text to compact D-dimensional Euclidean space. The mapping embeds text into the surface of a sphere with a radius of 1 and a center of origin. In this Euclidean space, distance indicates text similarity. As shown in this figure, there are 3 authors, and each authors have 3 articles. Texts of the same authors have a small distance, and the text of the distinct author has large distance. To realize the vision above mentioned, we define a triplet at first. A triplet consists of an anchor, a positive, and a negative. The anchor is the target text. The positive is the text of the same author as the anchor, and the negative is a text of the different anchor from the different author from the anchor. So our method embeds these three texts into the Euclidean space. Initially, this text will be embedded into three random points on the surface of the sphere. So the distance between the anchor and the negative is uncertain relative to the distance between the anchor and the negative. To separate the anchor and the positive from the negative, we propose triplet loss function. This shown in the right figure. This loss function aims to net the squared Euclidean distance between anchor and the negative greater than the squared Euclidean distance between the anchor and the positive. To better separate the anchor and the positive from the negative, we introduce a margin. It's just like the margin of spot vector machine. So we define the triplet loss function as the L for each triplet. If we expect the the squared Euclidean distance between the sum of margin and the squared Euclidean distance between the anchor and the positive should be not greater than the squared Euclidean distance between the anchor and the negative. So the difference between these two values is the loss value, and the minimum of this value is 0. Based on the previous triplet and triplet loss function, we propose a novel model architecture. Showing in this feature, the input of the model is a triplet. It consists of an anchor, a positive, and a negative. And the output of the model is 3 Euclidean embedding. They are processed by L2 So its 3 text will be embedded into the surface of a sphere. The loss function is the triplet loss. It can separate the positive and the anchor from the negative. In particular, the deep network is flexible and optional. Next, we will discuss the selection of these deep networks. Okay, we will discuss the selection of these 3 deep networks: fast text CAA Ingram, sign text CAA. Fast text is a fast and lightweight model, and it's effective for the problem of text classification. As shown in the right figure, the network of fast text has 3 layers, and it has just one simplified hidden layer. The input features are embedded and averaged to form the hidden variable. So fast text has lower complexity and higher computation efficiency. CAA Ingram has been proved to be an effective network for authorship attribution. As shown in the right figure, the input is character Ingram. And this model consists of embedding convolutional and max pooling layers. Convolutional neural network has made great progress in text classification. CAA Ingram has higher complexity than first text, but experiments show it has higher model performance. Compared with CAA Ingram, syntax CAA introduced syntax level features as input. As shown in the right figure, syntax CAA consists of 2 embedding, 2 convolutional, and 1 max pooling layers. So syntax has a high complexity and high model performance than CAA Ingram for the ownership attribution. In conclusion, for these 3 deep networks, if the network has a higher complexity, then it has a higher performance. As shown in the table, fast text has a lower complexity and lower performance. When the data size is large, to accelerate the training of the model, some performance of the model can be sacrificed. So fast text is suitable for large data size. On the contrary, syntax has higher complexity and higher performance. So it's suitable for small data size. The selection of deep network can be determined by the data size. So in compromise, we choose CAA Ingram as our deep network. In summary, we propose a novel model architecture. It uses a triplet loss function and deep network of CAA Ingram. Next, we will discuss the triplet circulation strategy. Given there are 100 authors, and each authors have 100 articles. So each author has 98 meaning triplets, and all authors has 9.8 meaning triplets. So it's impossible to use all the triplets to train the model. So to accelerate the model training, we have to propose effective triplet selection strategy. So next we will discuss our novel strategy, such as random selection and dynamic selection. Firstly, let's briefly introduce random selection strategy. This strategy randomly selects triplets as shown on the left. Firstly, for each author, we randomly select a number of anchor positive pairs. And the quantity is proportional to the number of this author's articles, and it doesn't exceed the maximum of these author's articles. Secondly, for each selected anchor positive pair, we randomly select a certain number of negative to compose triplets. random selection is simple, but selected triplets may be not efficient for the model training. So it's so necessary to select to propose selective effective triplet strategy. When climbing the mountain, if we mostly walk on the flat road, we will need to walk a longer distance to reach the mountain top. So, inspired by the mountain climbing, we propose a dynamic selection strategy. Firstly, a dataset is evenly and randomly divided into a number of partitions. Then, for each partition, we select anchor positive pairs as the random strategy. Then, for each selected anchor positive pair, we randomly select. We should firstly construct negative candidates. This candidate should satisfy its following condition. The squared Euclidean distance between the anchor and the negative should be not greater than the sum of the margin and the squared Euclidean distance between the anchor and the positive. And last, we will randomly select one negative from these candidates. So, these selected triplets have a positive impact on their loss value. So they are efficient triplets. Next, we will show the experiment. Before the experiment, we prepare a dataset as follows. Firstly, we crowd articles from 8 websites such as Huxiu.com, Lianyun.com, and so on. And then we pre-process the raw data. For example, we remove incomplete and duplicate articles from the raw data. And we also remove the duplicate authors as among multiple websites. And to make articles truly anonymous, we deleted the author information in the article, such as author name, WeChat ID. Finally, our set had about 130,000 articles and 3,600 authors. We use Tesla P4T as the GPU, TensorFlow and Keras as the platform for deep learning. In order to explore how our master fares against the other master, when the number of authors increases, the authors are sorted by the number of articles firstly. Then we choose top 5, top 20, top 50, top 100, top 500, top 1,000, and top 2,000 authors as our dataset respectively. Besides, to balance the number of the articles for each author, we choose no more than 100 articles. And the train test split is 8-to-2. To straightly compare our master with the other master, we use F1 to evaluate different methods in ownership attribution. And our baseline as follows: CAA Ingram, CAA Word, and Ingram SVM. The first two methods are based on deep learning technology, and the last method applies the features of character engram. We can see triplet selection strategy is critical in our method. So firstly, we compare these two triplet selection strategies. As shown in the left figure, dynamical selection strategy has a significant improvement over random selection strategy, especially when the number of authors is large. Next, let's compare our method with other baselines, as shown in the right figure. Compare column 2 and compare column 2 with column 4 and column 5. We can see our novel method has better F1 than CAA Word and CAA Ingram. Compare column 2 with column 6. The Ingram SVM has better F1 than our novel method when the number of authors is 50 or 100. And in the whole, on the whole, our method has obvious advantages than other baseline when the number of authors is large. Finally, let's summarize our work. In this week, we have made some contribution as follows. Firstly, we design a triplet-based method, and it's proved to be effective. Besides, we built the first Chinese dataset for ownership analysis. And we designed an effective triplet selection strategy, and it's proved to be effective. And experience show that our method have better performance than other baselines, especially when the number of the author is large. And in the future, we will experiment on more datasets, and we will further optimize the deep learning networks under the triplet selection strategy. Also, we will apply our method in all the clustering and all the verification. So that's all. Thank you.
Thank you very much, Lou.
Okay.
Unfortunately, we do not have time for questions at the moment, so I'd like to invite anybody who would like to pose any questions to the speaker to email him at the address on the screen just now.
Yes, thank you. If you have any question, please contact me with this email address. Thank you.